I'm Mike Gage at University of Rochester. I've been working on this on WeBWorK for a long time. One of the things that I particularly like is that while I did write a lot of WeBWorK at the beginning, the percentage of WeBWorK that I wrote is decreasing steadily. And that's due to all of the people who've joined in to help make this a kind of a communal effort and to improve it. And that's actually kind of the underlying theme of what I'll talk about in terms of the history, is that there are a lot of people involved in this, and there's a lot of room for even more involvement. We're nowhere near perfecting the use of online homework as far as I'm concerned. And an open source community such as WeBWorK is really a great place to do experiments and find out how we can do it better than we're doing it currently. The commercial packages is kind of, they're not completely static by any means, but they're a little bit more closed, and you use those the way people intended you to use them. WeBWorK, on the other hand, you can use it the way we intended you to use it, but you can start using it in your own way, and a great many people have. So I'm going to talk about a brief history of WeBWorK. All the PDF version of this thing will be available online. I think I sent it already to John and who posted somewhere. I'll talk a little bit about the history of WeBWorK. I talked about this last year at a workshop in Hong Kong, and so there's a web page there that the Hong Kong University of Science and Technology hosts with the talks that I gave there, which you can use to supplement what I'm going to tell you now. I'll tell you a little bit about library tags. They were already mentioned, a little bit about how to send in reports of bugs on the problems, because despite 20 years of work, there's still bugs in nearly everything. And I'll give you an overview of Github, which is a very useful way of collecting the software in an open source project, and allows everybody to contribute in a somewhat organized way, and allows the software to be vetted a little bit before we start before it goes into general distribution. So how did it develop? Well, it started at the University of Rochester around 1996. Apparently that's when the Earth cooled. We need to grade all students' homework to keep them motivated. That was the directive. And Frank Wolf and the physics departments have been using Kappa, now called Long Kappa, which was something more or less like WeBWorK. It worked well for physics courses, for physics problems, which all have the form of a kind of a word problem with some numbers in it, but it didn't work very well with mathematics, which had a much wider range of the kinds of problems that are asked. Arnie Pizer and I are the people who started on this thing, and we were joined shortly thereafter by Vicky once we started getting our NSF grants. It was first used in classes in 1996, so I guess development actually started a little bit before that. We got our first support from the NSF in 1999. Vicky started analyzing the results of what it was we were doing at that point. We received the ICTCM award in 1999, which was a big boost. Here's some of the people, you'll recognize many of them, they're still with us. Another thing that I'm really pleased about with WeBWorK is that the people who start working with this thing, many of them stick with us for a long time. So around 2004, we started on the current incarnation of WeBWorK, now we'll call WeBWorK 2. It was first released in 2003. MSRI supported us for a workshop in 2004. When the people you see in the pictures there and a few more got together and basically got everything. Things were kind of in position, but over 4 days we got it so that it actually worked. Sam Hathaway was a student at the undergraduate University of Rochester. He continued to work as a developer for some time after he graduated as a consultant, and eventually got a full-time job as the director of homework at Freeman publisher company. So Freeman's been, as a result of that, Freeman's been fairly sympathetic to WeBWorK, and actually, I think, uses WeBWorK to a large extent as its homework delivery platform. In 2007, American Institute of Mathematics supported another workshop. This was a combination of experienced people and people who were not experienced, less experienced. It was kind of simultaneously a workshop for getting things done and for outreach at the same time, and an awful lot got accomplished. By this time, we had hundreds of instructors writing questions, and we had around 12,000 problems in the National Library at that point. We had, I would say, half of the people here, or maybe just a little under half, were contributing significant ways to the macros and so on that help you to write your PG problems. In 2009, Math Objects was released. I think it had actually been kind of around for a while before. Gavin LaRose added gateway quizzes. Math Objects was done by David Cerrone. Both of these people have probably talked to you. We started a preliminary Moodle interoperability. It was done by a student at University of Rochester. I'll show you a little bit more about that in a minute. We also have been started an attempt, which has continued to this day, of trying to basically integrate anything that looks like it would be useful in a problem, try and make it so that WeBWorK can use it. So GeoGebra has been integrated. Java applets were integrated, and they're now somewhat deprecated because you can't, they're not safe. Flash is somewhat the same way. It's certainly been integrated. Whether or not you can use it on all your devices or not makes it a little bit less attractive than it was in 2009. In 2009, we got an NSF dissemination grant, and this really is, things went from, WeBWorK went from being kind of an early adopter type of thing with maybe 100 institutions using it to a much bigger deal. Let's see. So the way we sold this is that we said, well, we've got a software, online software that's pretty effective, but only people who are adventurous are likely to use it, so we want to make this available to a larger community. So we were going to do it by holding semi-annual consultant workshops. MAA would host courses for other institutions because one of the biggest barriers to starting this, as you're probably aware, is setting up your own site. It's not so much WeBWorK, but you have to set up an entire Apache server, and that's quite daunting. The MAA and adding WeBWorK on top of that makes it even more daunting. So anyway, that was the plan. We were going to go from 150 institutions to 450. Well, we did pretty well. We had 150 in 2009. We had 490 by 2011. By 2013, we had 670. 2014, we had 768. I didn't have a chance to look just before I got on. I don't know how many we have right at the moment, but you can find out by going to this WeBWorK site, which is on the wiki. And if you don't know where the wiki is, I will show you the link in a few minutes. This is what it looked like in 2011. The red pins are people who have their own servers. The blue pins are ones who are using the server at the end, hosted in MAA. This is what it looked like in 2013. Notice the MAA server really took off. Nothing like free hosting for a year to attract customers. Here's what it looked like in 2014. You can see it's spreading abroad, not really quickly, but reasonably quickly. And this one I took just this morning. I did have time to take a picture of it. It's a little denser than it was. It's a little hard to tell for sure, but I want to show you these. I blow up this lower left-hand corner here in southern Texas. All those green guys. So that's University of Texas, Panama, Pan American, is hosting high schools. And so there's perhaps 30 satellite high schools that are being hosted by them, and which are using WeBWorK. And there's some other green pins also. I think that this is something I've been advocating for some time, and I think that this hosting for neighborhood community colleges and for high schools and things like that is probably going to be the next growth spurt for WeBWorK, if there is one. So with lots more people using it, and people, who are a little, again, not experimenters who will try anything and make it work no matter what, but people who want things to work the first time or at least the second, we had to get our act together to make that work better. The web actually didn't change that much in terms of form between 2000 and 2006, so we had a little bit of more leeway than we might have had to get Web 2 going. The last 5 years, the interface to the web has been changing enormously, and we're struggling to some extent to catch up, including targeting mobile devices. This has certainly become steadily more important, and we have a ways to go to make this, what we're doing, work on really well on mobile devices. So the way in which we went on to fix this was that we started to have code camps on a regular basis. We'd had one or two that were just planned as one-shot deals in which we would get WeBWorK to the next level. We stopped worrying about outreach so much since we were already way beyond our goal, and we started copied Sage, which is a Mathematica, open source version of Mathematica, and started to have code camps in which we were bringing together people who were already reasonably knowledgeable about WeBWorK and have them pick one feature of the code and then try and get it to work better. So we've been averaging and we had money from the grant in order to do this. So from 2012, we were averaging about 4 code camps per year up until last year. We went through several versions of WeBWorK with approximately 2 releases a year. There was a camp in Winona, one in Rochester, one in Fitchburg. There's a whole list of code camps. You can go look at them. And incidentally, I'll mention this again later, but this is a good place to read about the history, or a good way to get a feeling for the history of WeBWorK, because people have been periodically posting blogs, personal blogs, about the work that they've done with WeBWorK. So you'll see new features here. You'll see summaries of what was accomplished with each of the code camps, that kind of thing. Here are some of the key developers who've come on recently. Jeff Gale, we were just talking about. Peter Staub, who's working on WeBWorK 3, which is mostly a front end for instructors that will allow the choosing of homework sets and so on and so forth in a way which feels more like you're on the desktop. You can drag and drop things and things like that instead of having to do all this text. Paul Pearson, you know, and JT, you know. Here was our release schedule. I just updated it a little bit from one talk I gave last year. We released 2010 in 2015. Sorry, 2.10 in last January. And one of the big features that this had was something we developed at our code camp in Portland last MathFest, was the accessibility aspect. Jeff Gale in particular did a lot of work with advice from Greg, sorry, I'm blanking on his last name at the moment, Krause, that's it, and Alex Jordan, who's at Portland Community College. They were really pushing to make WeBWorK something that can be used by people who have sight difficulties or dyslexia or various other kinds of things, because you certainly don't want to start depending on online homework if it's going to freeze out a sizable portion of your student body. So accessibility has been a big push, and it turns out that WeBWorK is actually quite far ahead of most of the published versions of online homework in its ability to be used by screen readers and the like. Most of this is due to the fact that we use MathJax. Something that David Cervone is responsible for developing, and MathJax has put heavy emphasis on accessibility as well. The release this summer, and available now in the develop branch of WeBWorK, will include things like just-in-time homework, just-in-time assessment, and I forget what R stands for. But it allows you to do exactly what Vicki was talking about. If somebody can't do a homework problem, they get too many wrong answers, so it's say 5 or 6 times. What will happen is you can the homework will expand, and there will be a bunch of auxiliary problems that you can do first, and then you can come back and do the original problem. So this was commissioned by Alina Duca at North Carolina State University. She got a NSF grant to do this, and commissioned Jeff Gala to do a lot of the programming for it. They've used this quite a bit at North Carolina State. I have not had a chance to use it much myself. I'm actually testing it now. We're going to pull it into the main branch, so it will be distributed probably in August. It will be part of the standard part of WeBWorK. So but it's exactly how to use it best is, I think, still there's lots of room for experiment. Let me talk a little bit about the library tags, and I guess the best way to do it is to just go look at it for a minute. So I'm not looking at the library itself at the moment, but I'm looking at these problems. And if you turn this on, and I'll go back to the screen in a minute, it tells you how to turn these on if you want them on. But every time you look at a problem, you can choose what the subject should belong to, what chapter it should belong to, the sections that it belongs to. Guess you have to have chosen a chapter first, and say something about the level of it, and then you can save it. Now, this is not made available for all instructors, but it is, and in order to do this, you need access to the library. You need to have been, your homework course has to have been given permission to save things to the library and so on. But this is a way in which you can go through and help with the tagging process of tagging the problems in the library. You'll see that if you go to the library browser, you may already have done these kinds of things, you'll see that you have similar kinds of things here where you have the subjects and chapters and sections that you use to search and find problems. And once you find them, you get levels that tell you something about how hard they are, and so forth. So these have been added by John Jones and the people who are working on updating the OPL. They're meeting, JT's part of the group there. I think they're meeting in the beginning of August. This group has done enormous things to, well, what they've actually done, we used to have 35, here's 28,000 problems or so in WeBWorK, in the library. I think we used to have 35. So this is progress, because duplicates are being weeded out, problems that are probably not quite up to snuff are being weeded out, areas which need more problems and then different levels of difficulty are being identified. This library project is extremely important and is a good way to get into learning how to write better code or just finding out what's available within WeBWorK. So just as a, you can, by the way, explore this a little bit more on your own. With HKUST, these were 101, 102, 103, and so on and so forth. These were all demonstration sites that I set up for people at Hong Kong University last year. And you can log into them using Prof A, password Prof A. Don't expect your work to stay there for any length of time. Don't write anything in there you want to keep secret, because everybody else knows the password also. I won't guarantee that every single problem works. This was set up last year, and there's a few things that have changed, and it's possible that some of the problems work and some don't. But it's a good place to explore. It was meant as a demonstration last summer of all the new features that we created over the previous year. So one other thing that you can do, if you see a bug in a problem, you can report it. Let's suppose we're looking at the demo problem here. I start to edit this problem, and I decide that there's a bug in it. So right here, it says I'm supposed to report a bug to the problem. So when I click that button, I'm taken to a repository that will have, I'm going to copy it just for a second here. I'm taken to a repository that keeps track of bugs, and people come in and fix these bugs. You can do this with all of the software on WeBWorK, but the fixing bugs and problems has actually been fairly efficient, and Paul Pearson can speak to it a little bit. He and John Jones are probably two of the people who fix most of the bugs. And you can get in on that too. So what happens when you click this the first time, you won't immediately be taken to the bug repository, Bugzilla we call it. The way I was, the first time you will be asked for your email address because it wants to be able to email you back when your bug has been fixed. That's about all you need. Just put in the email address and you make up a password and you sign yourself in. And as long as they set a cookie on your computer, and as long as you're using that same computer, you will the same thing that you will be taken immediately to Bugzilla. There's no delay in being able to report your bug. If you're on a different computer, you may have to enter your password again. That's about it. Anyway, it's a very short process. And what's being sent is a URL which tells me exactly which library problem I'm looking at, and it tells me which problem seed I'm looking at, because often problems will work just fine with some seeds and not so well with others. And this gives the person who's finding the bug in the problem a lot of information. And then you can paste in a summary of what's going wrong. You can paste in some description of what's going wrong. There's no need in this case for me to report the entire text of the problem because it's a library problem and the person fixing the bug can find it themselves. But if it's a custom problem of your own, you might want to paste in the code. If you figured out what the bug is and you want to report your fix for it, you can paste that in. In any case, this is again another good way to participate. How do you find things? This is one of the more important things I can tell you, because after the course is over, how do you get more information? Well, you can write JT and me and David and all the other people, but you can find some things out yourself. So there's an enormous amount of information in the wiki. Wikis are a little like the web as a whole. There's an enormous amount of information, but finding it can be a bit tricky. So there are two search engines, one here and one right here. This is an internal search engine for the wiki, and this is one in which we've basically it's a regular Google search, but it's slave to the sites that involve WeBWorK, and so it's got a higher hit ratio than just Googling in general. But these are good ways if you can kind of guess the term that you're looking for, like you want to find out about release 2.10, type that in here and you'll find at least one of the releases, and then from there you can work your way up to the most recent release. Another thing to look at is on the side here, the forums. You probably already know something about. There are a lot of people who ask questions and answer questions on the forums. It's really quite active and very lively. In order to be able to ask questions on the forums, you have to sign into the wiki. So the membership in the forums is controlled by the wiki, not by the forums themselves. So the first step is to sign into the wiki, which, again, you have to give it a name and an email address. And then you'll be able to post to the forums. The blogs, as I mentioned before, are give personal information about things. Let me get a bigger picture of this thing. Okay, the problem here is that it's not HTTPS, it's just HTTP. I thought I'd fix that. Okay, so here's the front page of the wiki right here. The forums I told you about. Here are the blogs. There's a post that I just did recently on embedding WeBWorK in Moodle quizzes. I'm going to tell you about that in just a second. And then HTML pages, I'll tell you about that. I'm going to tell you about this too. This is Jeff Gala has put 3D images back into WeBWorK. without Java. Here's John Travis's announcement of the course that you're taking right at the moment, and so on and so forth. Here's a description of the accessibility in 2.10 from Jeff Gala. Oh, somebody, I'm not going to talk about this, but here you can read about it. This was something that Alex Jordan at Portland Community College really wanted, which was this show me another idea. So a student has gotten this right, and now they want another problem of the same type that they can work on. This is a feature that you can enable in WeBWorK and set up. I'm not the best person to describe it to you because I haven't actually done it myself. But in any case, here's again, I'm not going to have time to cover all of these things. There's a bunch of different contexts. These are things that David can talk to you about. There's many people working on this and many people contributing ideas, and it's a little hard to keep track of all of them, but the blog place is a good place to see what the features are and people have been willing to write about. And incidentally, if you are, even if you didn't invent the feature, if you start using the feature and would like to give a user-friendly description of it, put it on your own blog. You can do that on WordPress or blog post or something like Blogger, something like that, and just send the link either to me or to actually to any one of us. Jason Aubrey is the other person who maintains this wiki, and we'll add your name to the list here of people whose blogs are being aggregated. The idea behind a blog aggregator is that most of us post like once a month, and nobody would ever, if that often, and nobody would ever read us. But if there are 12 or 13 people posting once a month, well, then the blog's kind of worth looking at. IRC is an online chat type of thing. That goes up and down in terms of usefulness. It's a good way because it depends on how many people are hanging out right at the moment. But those people who've been longtime developers of software and so on are used to using these kinds of things to helping each other out in real time. You can also just use messaging and Google Talk and various things like that. IRC kind of predates that. One last thing, just because it came up recently, this is the databases, and we set up a bunch of databases with various things. The site list is now gone onto the front page, and these things I think we never filled out. The WeBWorK references also we have better uses for, but better places to look up references now. But the macro references can still be quite useful. You're trying to, like, is there a program that plots functions? And this is fairly old and not that well maintained. The descriptions probably won't link to the actual descriptions, but at least tells you what kinds of things are available and in which files that they're in. So particularly for people who are developing things, this can be quite useful. And that might be more information than you actually wanted. Okay, in any case, this is a good place to look for all kinds of things. Community of users is another place. Mailing lists, for example, if you really are interested in getting into development, you should sign up for this guy right here. The other two are not, this one in particular is not heavily used. This is no longer used, in fact. We really should get rid of it. WeBWorK bugs will report to you whenever anybody else reports a bug, in case you're interested. Okay, back to the main event here. All right, how does GitHub work? So again, this is a way about how would I submit a problem to the library. So what you do is I'll go through this cycle first, and then I'll show you the sites that are involved. What you do is you create your own GitHub. I can't tell you the details of that right now, but if you go to github.com, it's an open source / commercial type of thing. It kind of does both. It's trying to host all of the open source, or at least all of the software repositories of people who are doing active development. And it's got very good instructions for how you can get your own software repository or GitHub. What you do is you create a copy of our GitHub, say the WeBWorK library. That gets pulled over to your copy over here. And then you can also download that to your laptop or your desktop machine, wherever it is you're doing your development. When you create a new problem, you push that problem up and you test it to your satisfaction. You push that problem up to your GitHub right here and then announce to the world that, hey, I've got a new problem. I'd like to contribute it to the Open WeBWorK library. That's called a pull request. The editors, Paul Pearson, people like that, over here, look at your pull request and say, okay, yep, that's a good question. We'll pull that into this library here. And then you go through the cycle again. You add more questions. Typically, people don't just post one question. Typically, people will just, they'll write a bunch of questions for a course, and then they'll post them all at once. Here's what the WeBWorK Open Problem Library looks like. If you get to this thing, you basically need, GitHub.com Open WeBWorK will get you to our repository, and then it's one of the subheadings is WeBWorK Open Problem Library. That's the one you're most likely to use. And in here are this is all the software, the contents of all of the problems that are in the library. They're actually in this subdirectory right here. One of the things that happens when you have a new problem and you'd like to contribute it and people don't have time to check it for tags, or if it isn't tagged yet, they can be contributed over here in the contrib area. And this is kind of a holding area where people can get at your problems. Maybe they're not sufficiently tagged to be part of the official library, but you can point to your friend and say, I contributed a whole bunch of problems. You want to grab them? Here they are. And people can college. Here's a bunch of Calc 1 problems, probably contributed by Paul Pearson, and here they are. I'll just get you started on the process. If you're looking at this point right here, and if you've already set up your own GitHub, you can say that you'd like to fork it, and they would say, where would you like to fork this repository? And I would click on Engage. And it's grayed out right at the moment because I've already forked it. I have my own copy of this. And when I do a new problem, I put it into my own copy, and then I issue a pull request. And that's this thing right here, create a pull request. And it creates a pull request back to the mother repository, namely the one you're looking at. So that's an outline of, I'm sure certainly not enough detail, but that at least gives you an idea of what the development cycle is like. There's the actual development takes place here. You make it public by publishing it on your own GitHub, and you show that you're willing to share it and would like it to become part of regular WeBWorK by issuing a pull request. And then again, it's a pull request. You're not allowed to actually put stuff into the WeBWorK library directly. You request that your contribution be added, and then someone like Paul Pearson and John Jones and so on goes in and pulls the problem that you've offered and places it into the library. This is in writing what I just told you. Leave this to, you can read this on the PDF version when we get to that. Source tree is a GUI interface for using GitHub, which I've come to find useful, and particularly for kind of routine types of things, and you may want to investigate that. These are some written references for GitHub, and I'll leave it at that. So now let me just say a few things about which you may or may not have looked at. Apparently you've talked about math achievements because someone asked me a question. Last year we put in the possibility of having essay answers. So you can add just an essay blank at the end of any problem you want and say, okay, explain your answer. This isn't graded automatically, but it is automatically collected, and then if you've got 20 students in the class, when you go to look at that homework set in the homework editor, it says there are 20 students who have answered this question. You need to go through and decide whether their answers are right or not. More likely just to make comments on their answers. Embedding GeoGebra applets is possible. GeoGebra now uses HTML5 instead of Java, and so that works really well. There's still a lot of development to be done with that. There are examples of graphical input with Flash applets. If you look on those Hong Kong HKUST sites there's things from Cleveland State University. That's Barbara Margolis and her crew produced a lot of Flash applets, a lot of graphical input, things like here's the function, draw a graph of the integral, the area under this curve. It's possible to use Sage, which I mentioned before, as a backup. Sage Interacts, JT can talk to you about that. He's created a lot of them. Ask Sage is more, again, there's some examples of this on HKUST, but so one really useful example of this is you want to have a matrix and you would like to have students row reduce it. So what you really want to do is to create the answer and then obfuscate it back to the original, because you don't want to have row reduction in which things don't come out to be integers and things like that. So Sage has some procedures that make that relatively easy. And instead of rewriting that stuff in WeBWorK, we just asked Sage to do it and then took the answers and presented it to the students. So that's something worth investigating. Scaffolding and sequential problems, I think this is, again, a growth industry. This is a way in which you can ask several problems and the student can't get to problem 2 until they do problem 1. I think in particular that this is a way in that WeBWorK can be used in a workshop setting and can help motivate and drive the workshop, keep students moving forward if they're working on these problems together. One parenthetical remark here, I think in terms of the environment for using WeBWorK, if you can get students to work on WeBWorK in groups, I think it is way more effective. There's even some research that would support this. But so one way to do that is if you have a workshop or a recitation session in which students actually start doing some of the WeBWorK problems, and you tell them that you want half as many computers as there are students, and they work on, then the 2 students can work on one of their problems, and then they can work on the other version of their problem. And by the time that they've been able to solve both versions, they probably have a pretty good idea of what's going on. I think that that's actually where a lot of the learning takes place. Okay, back to the main things. What's new this year? I told you a little bit about just-in-time homework. I think you should investigate that. One of the things that I was involved with was the Moodle quiz question for those of you who are used to using Moodle. And actually, you can get into this using Visitor. Again, those used to using WeBWorK, this may not be quite as interesting, but those used to using WeBWorK, Moodle will definitely like this. This is an actual class that I taught a number of years ago. It's a class in linear algebra. Here is the version of the homework problem that I did at the beginning. It's the first homework problem that was done in ordinary WeBWorK. And here is a quiz version of that. And I have quiz versions for every one of the homework problems that I did before. And again, for those used to Moodle, what you're seeing here is Moodle has a quiz type. It has way more, it's a little like gateway quizzes, but it has way more things that can be configured. And just a month or so ago, I worked it so that WeBWorK can be used as a back-end for solving mathematics problems. The Moodle quiz type is very flexible and very useful, but it sucked at mathematics. It basically couldn't, handle much beyond just ordinary numbers. And so the combination of these two has a lot of potential. It's still very much under development, but in fact, this already works pretty well with the modern version, the current version of WeBWorK and modern versions of Moodle. This you can get into just as a visitor. Hope that this works. So those who used WeBWorK some time ago, we had Java applets that allowed you to have 3D images of things. You could ask students, you know, which equation goes with which image. The Java catastrophe hit all of the web, including us. And now it was hard to figure out. Basically, browsers stopped allowing Java applets because they were a security risk. And so we've got new technology now using HTML5. Again, this is fairly new. There might be some bugs in it, but it works pretty well for me. We may eventually want to change, for example, how dark those are, various things like that. But it's probably good enough to use. Certainly good enough to use in experimental settings. And then the last thing, which is brand new this year, is the following thing. This is again sparked by Rob Beezer out at University of Puget Sound, and also Alex Jordan at Portland. They want to have a textbook. Rob Beezer has something called MBX, which is a way in which you can write once and display your textbook in many different places. You can print it, you can put it online as an HTML, you can print it out as PDF, you can print it out as a book, and so on. And he wanted to be able to include WeBWorK problems, not so much as homeworks at the end of the chapter, but example homeworks right in the middle of the text. So this is how it works. So you can download this particular HTML page. It's an ordinary HTML page, and you can look at its contents, and you can see how it works. This allows you access to any problem that's in the WeBWorK library right at the moment. And you can just embed it in an ordinary HTML page. You can, I mean, let's see, it's meant for practice. So, you know, you can get at the correct answer right away if you want, or you can work at it. It's kind of honor system type of thing. It doesn't do any recording of what the student does. This just sits there. It's a great way, for example, to show a colleague some of the things that you could do with it. And I guess the last thing I will do here is, this is the little piece of code that you need. That's all you need to do. You can download this thing here, and you can find your code. And if you don't like the problem that I've got, you can find the address to the new problem. That's the same path that's used in the library browser to tell you what or in your homework sets to tell you which problem it is you're looking at. You can just replace that with anything else that's in the library, and you'll get that problem, and it will be displayed on the HTML page. So again, just some things to look at, and that's it. Thanks very much.